Hello, viewers. Today we have the luxury of talking directly to the inventor of constant velocity motion system that's supposed to replace crankshaft, which has been dominant for more than a century. So let's give a warm welcome to Mr. Ron. Mr. Ron, can you please introduce yourself? Who are you and where are you from?
Yeah, I'm Ron Voegeli, and I'm from actually Florida, but I was born in Ohio. So
Uh-huh.
now I live in the state of Washington.
Uh-huh. So you were completely like born and raised in USA itself, right?
Yes, yes, I was.
Okay. So try us filling us some detail, as in like what were your early childhood? Some big events in your
Uh,
early childhood.
um, well, I'm the only child, had wonderful father and mother,
Mhm.
and I think it was pretty normal to what other kids grew up as.
Uh-huh.
I moved to Florida when I was 12 years old, and that was an experience.
Mhm.
I've always had dogs.
Okay. So when did you started to show signs of actually paying attention to mechanical systems and mechanics and all that?
Um, well, my dad did that a lot, and I was very uh, into what my dad was doing. So he worked for a company called American Can Company, and he made tools and dies and stuff. He was a tool and die maker, and he often made things that weren't common. So, as a matter of fact, when I was growing up, uh, we made a sailboat in our garage. Uh, my dad kind of designed it, but it was after another boat. But and then he built me a little go kart, and then we went and built a better go kart and raced that and stuff. That was a lot of my joy as growing up. Was I got into racing. My dad and I'd go to the super modified races once or twice a week
So
because he
this is
was
when we
into
are
it.
talking about like your teenage years, 14, 15 years old.
Before that, when I
Okay.
moved to Florida when I was 12, this was still in Ohio. So
Uh,
I was probably 8 or 9 years old.
so since basically you were a baby, you were driving cars.
Yeah.
That would be a fair way of saying it. So it's you had a very good upbringing, and you were very close to mechanical motions, and your father was also very adept at physically, getting his hands dirty. So when did you actually started to look into it academically, or were you more of like hands dirty kind of guy, getting your hands dirty?
Well, I was, I'm not sure exactly when everything transpired, but I was always playing with different engines.
Mhm.
And I helped another individual race his car. And we got it to handle real well. And I told my dad, everything is good in handling, but we just don't have the power.
Mhm.
And he said, well, work on something other than what everybody else is doing. Everybody's doing, fuel systems, electrical systems, the upper ends. Nobody does anything with the bottom end. Play with that. See what you can do.
So this is how you basically got your seed idea, where it's like, okay, let's look at where nobody else is paying attention to. And right now, basically in the whole landscape of combustion engine, we have a lot of options like supercharged, turbocharged, and multiple valve systems. Basically, we went from 2 valve to 4 valves. Right now, some companies are even trying 5 valve systems. Some are trying to change basically piston length while its engine is running, but nobody dared to touch crankshaft, and you directly went for that. So what drove this sort of madness where it's like, okay, let's directly tackle the beast?
Well, I believe it was my dad that told me the problem with a crankshaft is it only transfers the power at when the connecting rod is at a right angle to the throw of the crankshaft. And he said if you could design something that would put more power when where the combustion is the strongest, which is at the top, he said you'd have a really good item. And I don't know. I just worked on it. Worked on. My dad died in '76, so he never really got to see what I came up with, which is a shame. So he was actually my best friend. So
Okay, so you finally had a working idea, just a rough idea. When was that? Like, when did you say, like, okay, and I figured out like CV motion could be a thing?
uh, I started with the idea probably around I'd say 85 or 86. I didn't have it perfected yet. I couldn't. I had a little problem with the turnaround portion of it. And then I retired back in 87, 88, and didn't do much with it. But then, probably early 90s, mid 90s, I started figuring out how to make it turn around.
So you have been chipping away at it for quite some time. Would it be fair to say that?
Oh yeah, a long time.
Yeah.
It,
So,
it wasn't an overnight light bulb type thing.
so you have been chipping away at. So how many iterations would you say before you had that? Oh, this could work. Like because you said like rack rod was a very big issue for you to like basically the turnaround mechanism and all that. So did you had any cuckoo
Oh,
idea back in the days? Like right now you have
I
nine. Yeah.
yeah, I would say there was probably over 100 different
Mm.
versions of it before I got one that was easy enough to build and probably much more reliable than the others.
Okay. So how did you had your career that allowed you to look into it so realistically where you're like okay let's actually try to build it. So like tell me about that part basically your career part of it.
Okay, when I graduated high school and then I went to college, my 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 dad right before that he'd bought a company called Eco Engineering and Machine, and we made coin operated newspaper display racks. And in that, we did most everything from powder coating, injection molding, our own machine shop to do all the tooling, punch presses, and square shears and press brakes and all that. And that grew into be a fairly large company. And my like when my dad died, I had to take over the company as the owner operator. And so during that time, I was kind of too involved in the company to do much of anything except for what my dad was doing. And so that my design work on this upgrade to the engine took a kind of a back seat. So, but I was able to learn how to run all their CNC machines and stuff like that.
So you're talking about CNC machine before they became computerized as they are right now, right? Like very early CNC
Oh,
machines.
oh yeah. We started out with ones that were just a CNC machine that ran by a ticker tape. You made a ticker tape and you put it on the wheels, and then it just punched, like a
All
NC punch press.
so just after punch card, you are talking about punch reels. Basically, you are talking about that old of a technology. Like
Yes.
so I
Yeah.
think this at that time they only had CRT monitors for all the actual digital display. Or did they even had that display back then, like with CNC machine?
No, I don't think they had very many CNC metal cutting machines. That was late. Now maybe the great big companies, automotives, stuff like that, might have had them. I'm not sure about that, but us little guys under 200 employees, we had NC punch presses and NC press brakes that could, once it was set up, it would follow a routine.
Okay, okay, okay. Basically, just a automated manual machine. Like you program it right, and then just it just keeps doing it. It's not very flexible, not like today's where you can just like give a G code and it's like done. So
Right. You didn't compute. You didn't put it into a CAD program or anything. You went on the machine and you typed it up, or you went into actually we bought them from the railroad. It was a ticker tape thing, and you typed up, X with a number, Y with a number, and then a
Wow.
symbol, punch press it. It did all that.
Wow.
But that was where we started. So, um, but the newspaper industry kind of got changed when computers came out.
Mhm.
Uh, so I got out of that.
Okay. So you basically got your hands dirty in a like production environment with actual machinery. So I think you are quite competent with machine equipments, mills, CNC and all that by the time like 1980s rolls around, I think.
Yes.
Okay. So did you had any other passion about like let's say engines in other field like boat you have already talked about. What about other actual land racing and things of this nature?
Well, most anything competitive I liked.
Hmm.
Like a little girl that worked for us in our mechanism department, coin mechanism department. Her father and I were good friends, and he was a boat racer, a hydroplane racer, and he wanted to go into get something his daughter Cindy could race. So he built her a boat, and he and I worked on an engine. That was a 125 cc. It was a Honda Elsinore engine, and we put a rotating valve in it and just changed it. It was a two-cylinder, but it had a rotating valve and stuff like that. We
Like whoa, wait a minute, wait a minute. You are talking about rotating valve as in the valve was spinning cylinder or was a disc that was like opening and closing? What kind of
it
valve we
was
are
a
talking?
it was a disc, like it was 19,000 thick.
Oh, okay.
Uh, you
Flapper
know,
disc kind of.
it was a round disc like this, and
Uh,
it had a V in it. So when it would go to the opening, it would let the fuel and air run through it, and
uh-huh.
it would close rather than a reed valve.
Yeah.
And, and we built that. We got that 100. Well, I I don't remember the manufacturer, but there was the record was like 66 miles an hour, I think, and it's a 1 mile course.
Hmm.
So you had to go 1 mile, turn around, and come back, and the average of those two speeds was like 66, and you had to beat it by 3 mile an hour in order to claim a world record, and we did. Uh, I think we went almost 5 or 6 mile an hour faster.
Nice.
So we accomplished our goal. So it was move on to different things. Then we went to late model racing after that, which
Okay.
is
So did you yourself drove any high speed vehicle or like did you are always working at the engine?
oh the engines was my favorite part, but I also like to make them handle. So you had to do the chassis and stuff like that. But and being the president of my company, uh, my insurance wouldn't let me drive a race car in a race. So the only time I got to drive it was when we were testing it or something. I don't know if they liked that or not, but I didn't tell
So this is quite early on, and so I think you actually witnessed cars going from fully mechanical devices to electronic control units. Like, did you were you there during this transition?
them. Yeah, but I didn't do any of that. You know, I hired somebody to do that. I did make an electronic coin mechanism once, got it patented,
Mhm.
and Wurlitzer Corporation and Tom's Candy, both worldwide companies, they wanted to use the patent, so I let them.
Oh, nice. Did you got paid for that?
Um, yes and no.
Okay, that's weird.
Well, it's they wanted it so bad, and I wanted them to build it and let me have any advantage that they came up with when they built it. So
Okay.
that was my payment.
Okay, it
In
was
other words,
almost quick pro quo kind of deal, sort of.
yeah, in other words, I made a working model, but that was all I made. I didn't go further into it. The newspaper industry wasn't interested in. They were afraid people would break into it to steal the batteries and stuff like that. just because they had them. So they wanted the mechanical one. So anyway, I don't know. Don't know where it went from there.
So I think you have a lot of experience with patent because again, you are already patenting things in like late 1980s. So what would you say about that part?
I'm not understanding
Patents,
what.
patents. You have already patented something so far. So were you always able to use patents and like get patents done because that's a very hassle, like big hassle for most people. So I like you just said that I already patented this and gave them the patent. So that's a big thing. Patents.
Yeah, my a very good friend of mine again was a good patent attorney, and he worked at a patent place. He was like third or fourth from the top. His name was Norm Stepno. He's passed away now, but he, like the USA Today paper rack. That white one with the blue letters. I don't know if you have them in India or not, but I think you do. They're I patented the way to make that, and
Are you talking
there
about
was
blueprints?
no, not blueprints. The newspaper rack. It was like a little square rack on a pedestal, and the competition, the only other one that made them, had two seams, one seam down each side, and I made it in one piece and had a seam on the bottom,
Okay,
and
okay.
that was patentable. Then I did uh, automotive paint booths. I made a way to make those so you could disassemble it and reassemble it in 2 days, 1 day for each. Whereas the larger companies would take like a week to assemble and a week to disassemble. So that would be 2 weeks if you were moving. So I think I made I designed a fork truck. Wiggins bought that patent. Um, and it's a pretty unique fork truck. And then I designed several other things, quite a few. I got about 20, almost 30 patents.
Damn. So you've been quite busy since your life, so to say. Since you got into job, I think you have been printing out patents one a year, I think almost.
Yeah, well, sometimes it would be more than one a year, and then a dry spot where I didn't do any.
So, okay, so this is very early on. You had your newspaper gig. What after that? Because again, I think newspaper started to like whittle down. So what did you do afterwards?
um, well, here I am afterwards.
Oh, so, wait a minute. So you let go of that industry in 1990s, right? Or like bit.
Well, like yeah, but then I retired, so my wife and I were just traveling around a lot and
Okay.
had a motor home and a dog and a cat and a bird, and we went all over the place.
Wow. So
And then I was,
you actually had a quite a versatile life where you were actually traveling, you were patenting, and like you basically had a very rich life, practically speaking. So
yes,
that's a very
yes,
nice thing. Now, okay, so you traveled, and then this bug got into your head about this CV engine, right? This is the time when you're like, okay, let's really look into it.
yes.
Okay.
I
So talk about your machining experience. Basically, how did you had this idea to going into that AA engine model, that small engine model that you actually got into the patents hand? So,
well, that double A one was, I only designed it to be a handheld thing so somebody could see how the mechanism worked.
hmm
And then there was two people that one in Texas and one in Louisiana wanted to see a running engine. So Dave and I got together, Dave Haley, and we said, well, let's take this because we have it already built, and we'll just put heads on it and carburetors and make it run. The problem was when I built the first handheld one, I made it way over squared. It made the piston a lot bigger than what it should have been, but made it look cool that way.
hmm
So which was about, I think it's 2.68 to 1 4-stroke ratio. Well, a lot of engine builders said that you'll never be able to start it. It won't run. That's way over square. But we put it together to see what would happen. And at first it didn't run. So I said, oh, they're wrong. But we noticed that it would run if I oiled the rings up. And then I started talking to the ring people that I used to use for the boat engine that we built. And they asked me where I got the ring, and I told them. They said, well, we don't know how they made it, but our ring is round. That's why it's called perfect circle, I guess. And he said, I'll send you a 40 millimeter ring or set of rings. Put that in them and started right up. Didn't have any problem. Ran really good. So
Now,
matter
this
of
is
fact,
which year? When you had that actual running model, which year was this?
2015, 16, somewhere thereabouts. No, 2020, 2019, I think.
Okay, so at what point you came up along with the idea of like making CV Global as a company, like to make a company, make a trust, to figure have some people working for it? Like when did that happen?
That happened back in 2014 or 15, I think.
Okay, so who were the early investor in this?
Oh, I don't know. There were David Haley was responsible for getting a lot of the investors.
Okay.
We weren't asking for a lot of money. I mean, just we were pretty sure it would go. That's somewhere after that. Well, somewhere I started building those test stands, which you've seen, and the whole idea was to show that without any question, that we could take and transfer more power to the rotation.
Mm-hmm.
The linear pressure would go to the rotation much further and without a lot of problems. And it did. At the top of the cylinder at TDC, about, I don't know, 7% maybe of the stroke, 7.5% of the stroke, I think it is. It transfers over 1,200% more of the linear pressure to rotational torque. And where the crankshaft gets most of it, which is just before mid-stroke, we were 60% more transfer of power. And the real thing that came in, we don't advertise this, but where the combustion is actually the highest is at when it right after TDC, and that can be another 2 or 3 times more transfer of power because the crankshaft almost transfers nothing up there, and we transfer everything.
Okay, so how did you came up with the name of this constant velocity? It's a very curious name.
The piston travels at the same speed from 7.5% after TDC to 7.5% before BDC. So it's at a constant velocity.
Okay, so you are extracting a lot more useful work from each combustion stroke, so to say.
Yes, and it does it has a lot of see the crankshaft goes from a dead stop to slow until it gets up to its maximum speed, which is faster than what ours is continuously, and then it goes slower again. And like, let's say on an intake stroke, that piston right off the top, it goes pretty quick to get there, but it's moving fast. So it's moving air through at a constant velocity. So when it gets to the end of the stroke and the valves close, that stuff that's in it, the air fuel mixture that's inside there is already moving really fast.
Mhm.
So it pushes it through so you can get more air fuel mixture in there than what the crankshaft does.
Uh, so you finally succeeded in your desire of actually changing the core of the engine. So,
Yes, but
okay.
we can run almost anything that they've already
Uh,
invented in the top side.
Yeah, I think would be a very big advantage for your designs is simply because I've seen a lot of engine design, and because of the recent conflict in Russia, Ukraine, a lot of money has been poured into drones, especially because of Sahid drone. So you would be shocked the amount of money that is being poured into engines right now. Again, it's almost like a renaissance. So given the fact that you do not need to do much about in terms of tooling when we are talking about engine heads, basically the timing system, the valves, the piston ring, almost all of it is copy paste from everything else. Basically it's the same tooling, same machining can be utilized. I think that gives you a very big advantage in terms of actual production. Would you say that?
Oh yeah, and the one nice thing about it also is the the piston never touches the cylinder walls.
I think that's the biggest thing. That's how you are reducing so much of parasitic losses and frictions and all that. So I think that is a very significant thing.
It's significant because there's no loss as far as I mean our test stands show at the power that we were putting into the piston. It shows how much pressure was actually going to the sidewall,
Hmm.
and that pressure is lost from the pressure that's transferred to the rotation. So, uh, there's a lot of everything. The rings are the only thing that touch, and that's what's nice about the two stroke. We don't have to add any oil in the fuel.
I think that is the biggest advantage you have, that you can actually make two-stroke engine great again, so to say. So
Yeah, two stroke is probably going to be the engine of the future. I think it's a very what would you say, doesn't have very many parts to it.
yeah. So
Not like
I would like to clarify for viewers, if you are not aware, right now, engine efficiency is measured by brake-specific fuel consumption. It's a very simple number that gives you how much grams of combustion material you have to use in order to get 1 unit of power, 1 kWh. That is a very universal metric to measure any engine. It does not give a damn about how many cylinders you have. Does not give a damn about what is it's under square, over square. It does not care about turbocharge, supercharge. So right now, if you look into this world of basically brake specific fuel consumption, and the top most engines, like almost top 5 6 engines, they are all two-stroke engines, and all of them are generally very large, like I'm talking 10 megawatts to 30 megawatts, and they're generally used as a container ship engine. So just because you hear two-stroke does not mean it's like, oh, it's an ancient technology, nobody uses it. It's literally running the backbone of our world. So do not dismiss two-stroke out of the hand. And given the fact that Ron has made significant improvement on that itself, I think we can be looking at a renaissance of a two-stroke engine. Would you agree with that, Ron?
oh yeah, 100%. That's
Because I think whenever you are talking about valves and all that, you have to understand it's a physical mass that is moving back and forth, and that takes energy. And it's not even like old days of like spinning disc, or like some people are trying to make spinning cylinders. None of those things are ready yet. So you want to remove as many oscillating part as possible, so reduce phantom loss. So uh, and I think in terms of our design, because you are power strokes are happening at 90 degree, like each travel is happening at 90 degree. Could you explain that part, like rotation to travel, top dead center to bottom dead center, it's only happening in 90 degree? Did you design that, or is it changeable, or is the part of the mathematics of the core?
I think it may be changeable, but I haven't figured out how to do that. Uh, it's well, now you got me thinking more, but I don't know. Uh, it's probably going to be. I I wouldn't want to do it more than 90 degrees. I wouldn't want to do it at 45 because it's the shaft. Well, that's another advantage. Our shaft is rotating half speed to what the crankshaft goes.
Mhm.
Uh, and that's a big advantage as far as transferring it to in an automobile or an airplane or a helicopter. You don't have to have such a big gearbox because, as you said, the more gears, the more transmissions you have and stuff like that, the more power is lost in all of that.
Yeah.
And that's why I'm agreeing you 100% on the two-stroke is because it has all these less components. Yeah, people don't realize how strong these valve springs are.
Oh, I tried to
You have
physically press them. Like I can't even do that. It's like it's
oh, you can't do that. And if you go to try and turn that by hand, it takes a lot of power to turn that camshaft to push that valve down.
Mhm.
You know, of course, the spring's going to push it up. So on the other side, it's moving the camshaft a little bit, but you still lose a lot. So, and that's just that many more parts you have to build, and it has to be. The heads become more complex, the valves
Oh,
inside of it, and all that.
if you look into the engineering that went into very well valve timing, I mean, like, holy damn, those things are complex. Those are like ludicrously complex. So,
Yeah, and now they're even changing the timing while the engine's running, the valve timing stuff. They have some of the companies, the bigger automobile companies and stuff are changing it just to get another 0.5% better.
yeah. So, yeah, you have to understand, like, everybody else has already reached a kind of, like, saturation in terms of technology. It's ready, it's mature. So, like, the gains to be had is very minimal. So I've seen a lot of crazy idea, and like there is one company that is doing crank on crank. So basically you have a piston and then you have it's on an offset shaft. So they change the compression ratio while the engine is running. So engine could be like economic, it would be running at compression ratio of like 9:1, and then when you need power it could go 11:1 compression ratio. And they said about like it took so much extra engineering hour and all that. I'm like, you will take that money from the customer will get an expensive vehicle, because again nobody is doing donation here. So, and even
But
then they barely got like little bit of an extra boost, which again is commendable, it's a very good thing. But like I think your father was right on the money when he realized the core is missing. Everybody is figuring out the pistons and all that, turbo and all this and all that, but core is the limiting factor.
well, the other reason my dad said that too, because you know he was in the machining business before the Second World War,
Wait, wait,
and
wait, wait a minute. Before Second World War,
yes, he was
1920, you are
born.
talking about?
He was born in 1915,
Okay, okay.
and he went to work for American Can Company when he was 15 years old.
Okay, yeah, that's why I said like that goes back, like really, really back. Uh,
Well, and back then, making a crankshaft was not simple.
uh-huh. Lot of
Because,
manual labor, I think. Lot of manual
yeah,
labor.
a lot of changing. In other words, you'd have to machine this throw, and then you had to figure out how to machine that throw and that throw because it's not in line,
Mhm.
and that's a complicated way to do it. But they had special machines that do it. So now people are looking at, well, we already know how to make a crankshaft, so why would we want to go to this other kind of shaft, which is basically a gear and a rack?
Mhm.
But it can be done. Now it's going to take tooling to change,
Mhm.
but once it's changed, it'll be a lot simpler than a crankshaft.
Yeah.
Because now you got a connecting, you don't have a connecting rod, you don't have the wrist pins. There's all sorts of advantages. I'm sure there is some disadvantages that I don't see, but I don't think many.
Yeah. Um, and I want to know, why did you came up with the idea of hollow shaft? Was that idea like born out of necessity, or did you just made it to look cool? Because that's a very
Well,
unique thing of having a hollow shaft going through the main crank itself.
I didn't design it to become hollow shaft,
Okay.
but once I realized that you could, drill a hole all the way through it, then that gives you a lot of advantages that a crankshaft can never have.
Yeah.
In other words, you can have a common shaft and have 2 or 3 engines on one shaft
Mhm.
that are clutched on and off without putting the shaft to the side and using chains or gears to get to it. It's all right there.
Yeah, basically you reached a point where electric motors are right now where they have hollow shaft. Most electric motors have hollow shaft, and they have gear and planetary gear, differential, and then they have through shaft. So it allows them to pack the engine quite tightly. We can also do that if we have any sort of CVT or any sort of basically one offset done, and we can send it back. So it will make front wheel drive quite compact. So I think, and also I think weight saving is a quite a significant gain, right?
Yeah, well, there's not an awful lot of rotating mass in that hole. I mean, it's all there, but it's not like it's out. You know, that's the other thing that's wrong with a crankshaft, because the throws are way out to the side, and that's a lot of rotating mass. And then they have a counterbalance on the other side,
Mhm.
so that's a lot of rotating mass to get going, and a lot to get down. Where our mass is a lot smaller.
Yeah, and it's always rotating in the same direction. There is no acceleration, deceleration because of like changing lever arm length. So you have genuinely a lot of unique advantage. And I've also noticed into that rack rod that it's very well constrained. It's not floating. It's not just like relying on piston ring. It has like pins. Then it has gear teeth. Then pin on the other side. It's very well constrained. Was that a design decision, or like you thought of that as in like was it needed for better stability?
Yeah, well, yeah, that was part of the tricky stuff to get designed. But that also does another thing in there. When you have a crankshaft and you have two pistons, the pistons don't travel like this. The pistons go in and out
Mm-hmm.
because of, and that creates a lot of fluctuation inside the crankcase. In ours, the pistons travel exactly the same. The left piston goes exactly with the right piston. They're as if they're touched once. I mean, they are
Yeah, for
connected
mechanical
together.
reason, they're just one piece that is going back and forth. For a mechanical point of view, it's just one
Yeah,
physical
so
piece.
so it's moving the air inside, but it's not changing the volume of air.
Ah, yeah, yeah. So you do not have that pulsation that happens at the core point in the
Right.
crankcase. So yeah, yeah. And I think once we have like two pistons, basically two rack rod going back and forth, I think even the vibration would be cancelled out quite perfectly. So
Right.
yeah, because again, right now the world is moving towards range extender, and because once we go to electric transmission, it's quite smooth, quite like silent basically. So we have to make an engine that is very low on noise, vibration, and harshness. And I think just based on the mathematics of your design and the actual motion, I think you're gonna be quite good in that regard in terms of CV motion, in terms of vibration, and in terms of harshness.
Right.
Yeah. So, what else do you see this mechanism being used as?
Well, uh, there it has a good, being constant velocity.
Mhm.
We can take and make it into a relatively low pressure, high volume by rotating the shaft. In other words, it would do real good in uh, getting electricity from the flow of water,
Mhm.
because you wouldn't be wasting any water. Right now on a turbine, which is the common thing, there has to be quite a flow of water just to get it to start to move, and there's a lot of water. You know, a good a turbine is basically a propeller, and a good propeller, 25% slippage.
Mhm.
A really good one, they put little bends on the end of the prop and stuff like that, and they can get it down into the low 20s, but it's still that much. So in other words, you're losing a lot of water going through on a turbine, whereas we lose every ounce of water is used to generate power, and that power would generate electricity. So
And what
David
about air
Haley,
compressor?
the air compressor is the same way, and it's it'll compress the air as it's moving, because it moves at a constant velocity and stuff like that. So it'd take less power to do that. Now I did design another one. You mentioned it at every 90 degrees. I have one that's a 360, which is so it travels a lot further both ways. It's not good for an internal combustion engine, but it's really good for transferring, making water pressure because of it being constant velocity.
Mm-hmm.
Uh, you can have a lot of pressure and under smaller horsepower.
Ah, so there is already a lot of requirement for pressure washer from CNC water jet cutters to pressure washer and all that. So I think there is a lot of good that can be done. And do you
Yes.
think your system can be utilized for compressors of refrigerations?
Oh yeah,
Yeah, I think because
definitely.
if we can actually push the efficiency, basically we are improving the coupling efficiency of mechanical rotation to actual compression in the fluid, working fluid. So if we can actually improve that, that would be a very significant gain, especially in modern era where everybody wants to use CO2 as a refrigerant. So that puppy does require a lot of pressure. So improving even a little bit, let's say from a normal crank, it's let's just say it's 80% efficient from mechanical to actual compressed gases, and we improve that by 90%. That would be game changer. And especially the bigger the system you are talking about, the bigger the savings will become. So I think more than enough people would be willing to put some money down. Have you patented this part yet? Compressor or air compressor or
Yeah,
something?
yeah, we made one. It was that same AA01. We just made it into a compressor,
Uh-huh.
and that one um, at 30 RPMs we were pumping 60 psi.
Only 30 RPM.
Only 30 RPMs.
Damn, you don't even find motor that is that low RPM. So,
Well, I took the motor off of a one of our cylindrical grinders. Not the grinding wheel, but the other part. That turns the part that you're going to grind.
uh-huh.
I used that motor because that was variable speed, so we could start out at 0, but it only went up to 30.
Okay. Yeah, that's a unique thing. So I think if could you change that? Like, could you make it far more comfortable at let's say 1200 RPM, which is like easy to find
Oh
motors?
yeah,
Uh, because again, if you have to change ratio, gear ratio that much, we have to have like tiny pulley and then giant pulley to drive it. So
well, the one thing that I didn't share with you is the AA01. When we started out, since it was a hand rotating one, all of the parts were aluminum. The rod rack was all aluminum. The power shaft was all aluminum,
mm,
and it wasn't really designed to have any pressure to go, you know. And of course, a two-stroke. That's the other thing we didn't cover. The power case has oil in it, and it just stays in there. So that part's all right, but I we could get enough power out of it from razzing the engine, going from 900 RPM to 2000 RPM or something like that, and then down backing up. Well, that's hard on the aluminum, and
uh,
it's all 6061, which is the lowest grade of extrusion you can get about. So
but I think you built it more as a prototype rather than like actual production ready engine.
yeah, but a prototype, it depends on how you test it. If you want to test it, you want to run it for a half hour, an hour. Uh,
Mm.
we're talking 2-3 minutes max, and then let it, then try it again or something. But there's, I don't know, there's several ways to look at it.
Okay. So, so what are you planning right now? Basically, you already have so many patents. What are your future plans now?
Um, well, I'm helping a friend of yours and mine, the Being,
Mm.
uh, build an engine. So I'm uh, working on that. I don't know. I don't have much plans, I guess.
So, did you actually try once you actually had the idea, once you realized that this is a actual, it's gonna work, quote unquote, that timeline when it's like, okay, I think we have something that could work. Did you try to communicate with other people, other companies to show them like, is there a chance for, getting it into market? Did you try that?
Yeah, we had a meeting with an automobile manufacturer in Japan
Mhm.
uh, through a friend of ours. Uh, we got to meet this gentleman, and he looked at it and he thought it was great. Matter of fact, he complimented us quite well. And then he had his engine company in Alabama. Uh, the president of that and the general manager, he asked if we would go and meet with him. And David and I said we would do that. So we went there and met with them, and they were interested. Uh, I don't know if they want me to produce their name, but it starts with a T, so you can kind of figure out who it is. But,
Yeah.
uh, and they said that they had their engineer look at it because they still have one. As a matter of fact,
Wait a
the
minute, a working copy or like just a half-built piece?
just the rotating handpiece.
Oh, okay,
They
okay.
have that,
Okay.
and they they said that their engineer suspected that it would get probably into 70% thermodynamics from the 35 to 39 or 40% that they have now. Uh, and one of the things that they did say that they're really interested in was they felt that the emissions would be down small enough that they wouldn't have to have the expensive exhaust system that they have now
Yeah,
with all the
I would like viewers to understand this point that there used to be a lot of engine manufacture worldwide, even in India, even in USA, everywhere there used to be a lot of engine manufacture. It was not magic or black magic science back then. So you have to understand that the reason why slowly, slowly, brick by brick, day by day, most of engine companies went under is simply because of new emission standards. Like in India, we went from BSI 1, BSI 2, BSI 6. Even USA had its own system. Europe has like Euro 1, Euro 2, Euro 3, Euro 6, Euro 7. So brick by brick, making an engine is the easy part. Making a efficient engine which has low enough emission for modern standard, that's the hard part. So this is the genius of Ron. Basically, he figured out how to design an engine that can do that and basically be so far ahead that there is no competition. To give you numbers on this, like to actually communicate what we are talking about, let's say some company's engineer looked into it, best calculator, best computers, best supercomputer also, and they came up with the idea that engine could touch 70% thermodynamic efficiency. Well, what does that mean, right? What does that mean for you and me? Well, to give you a context, right now was one of the best, like second best, first best does not matter, it's like almost in the same category, which crosses 50% threshold, which is the biggest achievement so far in recent industry, that we have crossed that 50% mark. We have 51% engine. These engines are generally manufactured at like they're made to order, and one is from MAN, MAN. Now this puppy reaches 54.6% efficiency. Now to convert that into useful number, that gives you 154 grams per unit of electricity. Your normal car engine would be lucky to give 200, basically 200 grams only for 1 unit. And this puppy can reach 150 grams. This is in use right now. And however, our CV engine can cross this. Like, I think we can actually touch. Again, I do not have high hopes for four-stroke one because again, it has so many parts, phantom draws and all that. But I do have a lot of hope for compression stroke or with two-strokes variants, which we are developing thankfully with aviation industry for defense sector and unmanned aerial vehicle. That puppy could cross 150. Basically, we may touch 130. So, how do you feel your chances are, Ron?
I think they're pretty good. Uh, I I think we're going to get closer to the 100 mark
Yeah. So,
than your 150. But
yeah. Because here's the deal. The moment we touch 100, And the moment we get it verified from all the third party, because trust me, when we touch that, it would be like, okay, it's a scam. That's the first thing people will say, because again, you have to understand, for 130 years, and this, so many company poured so much money into it, and none of them can even touch, let's say, again, most of the engines that are in the market, you would be lucky if you can even touch 180. And I'm talking like Scania engines that are like very well efficient, very well oiled, and like everything is fine tuned. They barely give you 180 at like very specific RPM, very specific load. And pushing far beyond that, pushing beyond 150, it's not a little change. Many of you may be like, okay, who gives a damn about combustion engine? I would give you a one reality check that will help you to understand. Look into planet Earth's oil consumption, basically petrol and diesel, or you may even call gasoline. Has it gone down since all this EV craze? The answer is no. Nothing, like zero, zilch, no progress has been made. And again, we can talk more about that, because again, we are not using a range extender. To have a good range extender, you have to have CV engine technology. So right now, the world's fuel consumption is going up exponentially, even though China claims like they have made so much progress in terms of basically electrification and all that. You look into their fuel consumption every year over year, it's going up. So you have to understand, making an engine efficient will save the planet far quicker compared to switching to a battery system, which again, right now, it's basically just changing the pollution source. Rather than having pollution happening in your vehicle, it's happening somewhere in the mines where you are mining way too much material for your battery box. And electric vehicles are just a battery box with wheels. Motor units, awesome. Electric drivetrains, super awesome. We have been using them from ancient time, like 1903 and all that. That's the first year, I think, when humanity figured out series drivetrain with diesel locomotive. So we had diesel locomotive driving a dyno. This is back then, we did not invented alternator yet. So they were dynos were driving the motors at the wheel. So that's how diesel locomotive work. This is the earliest year. Then we built a diesel submarine. Again, the same principle. Diesel engine will run alternator. Alternator will charge the batteries. Batteries will run the propeller. So electric drive, awesome. Batteries, not so awesome. And if you look into the carbon footprint of batteries and all the associated penalty, like if you want to give yourself nightmare, look into acid mine drainage. Yeah, you will not be very happy about giant battery banks on your wheels. So trust me, making an engine, and specifically an engine that is so far ahead that there is no competition, it will save significant amount of fuel, significant amount. And at the other end of the day, I want to emphasize this part very clearly, that claiming things does not make any difference. Unless the customer gets genuine benefit, nobody's going to switch. And we had like data from, to give you a context, Toyota's first series parallel hybrid came into market in 1997, and it's still not the dominant force, because again, customer has to get the actual joy of using it, actual flexibility, actual money saving. So that's why we are so hell-bent on making our engine efficient while reducing the part count. We do not want, okay, what if we had this and what if we had that, and then we add all this, then we'll have a little bit more efficiency. No, we want the engine to be efficient on a fundamental level. So we have a bet. Ron and I have a bet. So if we touch 100, drinks are on me. If it crosses 100, Ron is gonna give drinks to everyone else involved with this project. So let's see who. I do not want to pay, man. I do not want to pay. So I hope you cross 100. At that point, it's your deal. So.
Well, the one thing that I have to bring up is when they were talking about the less exhaust system. Mm-hmm. They said, I don't know, I don't remember the exact number. It was 259 or something like that for the components in the catalytic converter. 250 some dollars that they pay for it for a 4-cylinder engine, and double that for the 8-cylinder engine. And that's a lot of dollars that they wouldn't have to charge for the vehicle if they could reach that. They felt pretty confident that they could.
Yeah. And again, right now, that's why I said like there is a renaissance happening, because again, people want range extender rather than having like ginormous battery. Like for example, Audi has a vehicle that has freaking 90 kilowatt hour. Ford pickup truck also crosses 130. Hummer almost touches 200. Tesla has like 75. These are ludicrous battery size. This is not good for the environment, not good for the pocket. That's why they are not successful yet. And what do I mean successful? simply once you actually notice that country's fuel consumption is going down. That's why it's not going down. It's huge. The batteries are huge. Now what we are offering, or any person with sanity is offering, is like, hey, stop the goddamn engine battery growing. Basically you keep the battery capped to, let's say, 100-kilometer range, and then put a range extender. 90% of the time nobody is traveling for hundreds and hundreds of kilometers, and when they do, we got the engine. It is efficient, and there is another benefit, because this using this series hybrid drivetrain, or what we classify as a range extender, we can keep the engine is efficiency island. All engines are quite efficient, and we would be exponentially more efficient, but unless you can keep the engine at that right RPM and right torque, you're not going to get the most awesome conversion. You may think reducing load saves fuel. It does not. So you have to load it precisely, perfectly. So that can only be done if you have a buffer. Batteries are buffer. So if we do that, then more people can afford the vehicle. None of them will have range anxiety, and everybody will be actually win. So that's why I am so hell-bent on actually making a good, compact, and low vibration, low harshness engine that people can just put and forget. 90% of the time they do not even have to think about it, and when they do drive for long duration, they're like, hey, I do not have to worry about range anxiety. So
I agree with you 100%.
yeah.
That's the way to go, because let's take I don't know if you have like a delivery truck.
We do.
If they're running that, and when they stop, like with the electric, when it stops, everything stops. But when you have an ICE, when it stops, it's just sitting there running.
Yep.
And that's taking off and sitting there running is a lot of emissions that we're putting out. And when you don't have that battery, you have a lot less power to.
Yeah, zero power. Practically, you have zero power. You have to keep running the engine. But if you have a battery, you have the luxury. It's like, hey, if the battery, let's say, realistically, you want your battery to never go down below 10% state of charge and never above 80%, because again, that's the most sweet spot. So let's say you are running the battery is only capable of, let's say, 3 hours of driving and all that. You drive for 3 hours, and then the engine turns on, charges the battery, and shuts off. You never have to, like, okay, I'm starting on the traffic and then randomly start the engine, turn it off, all that. You do not have to do that. That's why, like, ironically, our engine makes electric vehicle far more effective, far more well utilized. We can actually reduce the price where people can buy it. We can also make sure, like, if you're like, hey, what if I have to directly drive for very long range? You will still save money, because again, our engine will stay at the efficiency island. That's why it's a very critical to have range extender. And again, trust me when I say this, most of you who think we can just do batteries, please look into the emissions of battery and the penalty the environment is paying. So I rather have that penalty be as little as possible. So if you're like, hey, how about 90 unit of battery? I'm like, hey, how about just 30, 35? Me good. Again, I can sacrifice the car's frunk. I'm okay with that. I can make that sacrifice. I will live through it, because again, for 100 years we did not had frunk. So I think we'll be fine. But having a car that is like, hey, I do not have to worry about it, I think it would be a really sweet deal. What do you think about that, Ron?
Well, the thing that you're not telling them also, which is another really good point, is that the weight of the battery puts the suspension has to be heavier.
Yeah, absolutely.
Tires have to be heavier.
Undeniably so.
And you're going to wear out the tires a lot faster. So that's a lot more dollars it's going to be costing the car owner. But if you throw away that weight of the battery, then the suspension gets lighter, the tires get lighter. Now the brakes, you would say, would get lighter, but if they're generating electricity off of the braking power, that kind of compensates for that. But that's all costs a lot of money too. So you're going to either put the money up front, or you're going to save the money and not have it to begin with. But people don't realize that those tires, really, what they're used to now, getting 60, 70,000 miles, which 100 and some kilometers, they're going to drop that in half, and the price of that heavy duty tire is going to double in price. So it's no, batteries are really a downfall
Yeah,
dollars.
yeah. To give a mathematical context for people, when Tesla semi truck was made that was electric, it was so bad in terms of its carrying capacity because batteries were so huge. Government had to create a grant, not even a grant, I would say, a more of like a law where it's like, okay, if you have electric truck, you will actually allowed to increase your axle loading because again, if they had the same axle loading as every other truck, it would not have useful payload. So basically, you are wearing down your infrastructure, your bridges, let alone tire. I'm pretty sure you can live with tires, but you can't live with a broken bridge. So trust me, all of those will wear down exponentially quicker if you just jumped into electric system. And another aspect is how the heck you gonna charge like these megawatt class battery in middle of nowhere? It's like everybody's like, oh, we're gonna supercharge it, hypercharge it. I'm like, do you understand what 1 megawatt hour is? Like there are villages in America that are running less than that. You cannot just like ta-da, middle of nowhere, I have like 1 megawatt hour, 5 megawatt hour. It's like that's not how it works. And again, you have to pay for it one way or the another. You have to pay for it. And then people will be worrying, oh, USA does not have a good charging infrastructure because you have to pay for it. And once you have to pay for it, either you do it on subsidy or you just don't do it all. And that's the core problem. Batteries are huge. If we just shrink the battery, and again, that will also allow battery technology to catch up. Basically, right now, everybody is happy with the drivetrain. We have spent almost a century. And again, Ron can actually push that technology to Gen 2, and we're going to have even more amazing life out of it. And we spent so much money. Let's utilize that. Let's do not put giant mining side effects on planet Earth. Let's do our best to basically whatever we have, let's utilize it wisely. So, what do you say about that, Ron?
I agree with you. You said it all.
Yeah, that's the whole point. It's like I do not get this tech bro mindset where it's like, oh, we're just gonna have like giant battery. It's like, do you understand that A, the battery is not free. B, energy is never free, even if it's all solar. I live in India. We have more solar than you can count. And trust me, heck, my rooftop has solar. So trust me, we know solar. It's not free. You have to pay for the panel, you have to pay for the battery, you have to pay for the inverter, you have to pay a lot. And the more you have to pay, the less transition will happen. So let's keep the battery relaxed. Again, I do not want to make gearbox. Let that be very clear. I want a range extender. I do not like clutches. I do not like gearbox. I do not want those parts. Heck, I don't even like 4 stroke. I like 2 strokes because again, I do not want parts. Less parts, more efficiency. Again, you can look into the worldwide efficiency metric for actually understanding that 2 stroke is genuinely better. So fundamentally, I want to utilize what we have, the limited resource we have. I want to utilize it and actually have people who is like, huh, I'm actually saving money. My life is better. I want that. I do not want people to be, broken down because of inflation. And then it's like, okay, why fuel is expensive, why electric car is expensive, and why electric chargers are expensive. So this is a very, yeah.
Well, I don't know if they've come a long way in the batteries or not, but I think the battery's still the same way. The more often you charge it, the faster it diminishes.
Oh yeah,
In other words,
to give you a real world example, Nissan when they released it, they wanted to keep the cost low for better market penetration. They did not put a AC unit on the basically battery. Basically, the battery was uncooled or unheated, so the batteries wear out in only 5 years. To make sure the battery actually lasts a useful life, you have to air condition the damn thing. Like to look into tear down of BYD blade batteries. It has a evaporator on top of the battery to make sure the batteries are cool enough, and a heating element for winter times when it's like very cold. It has a heating element. So you have to understand the batteries are not as awesome as we think. We are working around its problem, and I'm like, hey, what if you can keep it small so it's manageable? And again, another aspect is that we throw away the whole electric vehicle because the battery bricked out. That's a really wasteful thing. And I'm pretty sure you must be from an era where people used to rebuild their engines and like cars used to last a very long time, like 10 years, 20 years, 30 years was like normal.
yeah. And well, you also have to add into the cost is getting rid of the battery.
Yeah.
I mean, you can't just take it to the dump and say, "Here's the battery." They're going to say, "Hey, that's uh that's going to cost you to dump it."
Yeah. Lot of hazardous material, lot of hazardous material. So yeah, it's a no joke, practically speaking. So
yeah.
so how do you see this technology catching up in next few years, so to say?
I, be honest with you, I'm not sure. I thought we would get further along than we are right now with a lot of things, and
Okay.
change takes time.
Yeah,
And
that's the most absolute truth you can talk. Change is very scary.
and the thing is, I understand industry. I mean, I was in industry, so industry only changes when it has to.
Hmm.
And if they have all their equipment going and they're making something and they can modify it a little bit, it's okay. But when you got to modify it a lot, it's this is going to cost us a lot of dollars. Let's wait until we have to,
Hmm.
and that's
Yeah.
that's where it's at.
Yeah, that's why we are so excited with Ahiravat because we are the one who is taking the leap of faith, and let's see how the world rewards it. And again, we are in a very good sweet spot right now because again, the world is moving towards a lot of new engines. There is one company that is claiming one-stroke engine. Trust me, it's a two-stroke engine. They just call it one-stroke for marketing reason. So there is a lot of new engines in the market. So let's see who's wins supremes. My money is on my engine, so. I think we're gonna win. And because the base advantage I think our engine has is lot of torque, lot of useful torque. When did you realize that our engine is gonna have such amazing torque characteristics? When you're simulating it or when you are actually holding it in your hand?
No, actually, with our test stands,
Okay.
our test stands give you irrefutable evidence that it will transfer linear pressure to rotational torque 2.5 plus times what the conventional crankshaft does.
And again, you guys have to understand that's at every power stroke. So we can either reduce the fuel load that is going, or we can keep the same fuel load and get far more work done. So that's and again, I will prefer having less fuel load, again, better emissions and all that. So,
Well, the less fuel load there again goes to weight.
hmm,
So if you make a smaller engine
hmm,
that's going to get the same horsepower,
hmm,
you have more room
hmm,
because it's smaller, or you have a less weight because it's smaller. So it's
hmm.
I would the two stroke. It's got so many advantages in that way because it's lighter, smaller,
Oh,
and
I don't think you have to sell two-stroke engine. The moment we show that we are at, let's say, the moment you show 100, the end. There is no conversation after that. There is no conversation. Drinks are on you if you are below 100, or on me if we are above 100. But we do not have to worry about the moment we have that data, final data. It's all sorted. So I don't think people will compete, like even complain about it. It's like if you're burning less fuel, you have less emission. We don't even need to run oil mixture into our basically main pistons and all that. So that's also another benefit. Compressor. So we have compressor, we have wind turbine, pardon me, water turbines, and anything else? Water turbines, air compressors, refrigeration compressor, combustion engine, anything else you have in your mind?
no, I think that covers it.
So yeah. So this
There's
was
a lot of stuff floating around in there, but
uh, how many patents so far? I think you had a very rich patent history. I think you should be at 30 right now.
how many I don't think it's quite 30. Well, if you count the foreign patents, it's over 30. But I mean, the actual single patent, you know, just like this CV patent, it's got different countries give us the same patents, but I don't count those. I think it's 22 or 23 patents.
Okay.
And there's several things that I come up with that we decide, like my last business was articulating rudders on a boat,
Mhm.
and I didn't patent that. I'm the only one that I know of that makes an adjustable articulating rudder.
Mhm.
Uh, things like that.
So, well, if we get a really good thermodynamic efficiency, you might even get Nobel Prize. So, we are looking hopeful towards that, especially in refrigeration. You have no idea how big that change would be. If we can actually achieve good compression efficiency in small scale with normal motors, that would be like, shut up, take money. That would be very
Yeah.
significant. So, anything else you want to add about your life to the public? Would you like to share with the public?
No.
I think you had lucked out in your friends department. You had very good friends and very good father, I would say.
Oh yeah, and mother, and
Mm,
I was very fortunate most of my life.
yeah.
I did have polio when I was younger, but most of that's history.
Damn, you're old. I keep forgetting about that part. It's like polio, man. Like that's damn. Like you went back, man. You went back. I think you have seen most of the modern technology come into existence, right? Like most
Oh
technology.
yeah,
Uh,
yeah. Uh, Things have evolved a lot, especially in the manufacturing
mhm,
industry portion. Now, maybe in others that I'm not aware of, but there's,
yeah.
uh, when the first CNC punch presses came out, we bought one, and it was so fast that we were having a hard time keeping up with shearing the metal to put in to have it. Things have just evolved around in every industry, I think.
Yeah, yeah, absolutely. We ironically after World War II, we have made tremendous progress, and I mean in every vector, every possible way. Because I think you were alive, aware in an era before mobile phone were even an idea. I think Ron was talking about when he used to have car phone, not mobile phone, car phone, where car had phones. I think you were also in that era when cars were like,
Hmm.
car phone. Motorola's like car radio became car phone. So, were there any TV shows that were your favorite from that whole life experience?
I like science fiction
Oh,
movies and stuff like Star Trek and stuff.
oh,
That's my
damn, damn.
favorite.
You must have watched Star Trek when it actually came out, right?
Oh yeah,
Next Generation or the original one?
I started from the first ones and kept going.
Oh, you literally watched the original one and then you watched the Captain Picard and all that, right?
Oh yeah,
Damn. That was, I think that was the peak Star Trek because what we have right now is like, I have no idea. It's abomination, but damn. But I think that was the golden era of science fiction. I think you watched Star Wars when it actually came out, right?
oh yeah, yeah.
How was the impact, like environment back in that day? Because again, we this is before mobile phones. So how was the impact in USA?
Um, I think a lot of people watched it. Some people kind of laughed at it. There was a lot of people that were, it's all comic book stuff, but yeah, they're doing what we wanted to do. I mean, there's we got a long way to go, but I think it's like everything else. Once they start, everybody's going to go in. If only we could get all of the people of the world to be on a similar page and everybody just be happy with everybody, we would be one heck of a world.
Nah, nah. I think we'll hate that. We'll hate that. I think you should have watched Matrix when it came out. You may have watched it. I'm not sure. That was
Yeah,
you remember it?
yeah, kind of.
Yeah, in that they had the concept that machines, the first world they built was a utopia. Everybody was happy, and men went mad in that. So they realized that you do need a certain level of chaos. So I think it's a good idea to want a world to like kumbaya and all that, but it's one of those things. It's like quirks of humanity, or you might even say like our cross to bear, so to say. So well, I just want to humanity to be smarter because again, I do not see any problem with humanity. I just see silliness. It's like everybody's like, okay, how can we like solve this? I'm like, you had the solution from 1997. You're just not using it. You had like, can you imagine if we actually build the engine and it's actually successful, and then the big companies are like, oh, why didn't you offer us? And you'll be like, bro, I was there. 2018, I came to you. That would be such a funny thing. It's like, bro, I was there. I called you. You did not pick up the phone. That would be such a funny thing. So,
Yeah.
yeah. So, anyway, any final thoughts you have?
No, I think we're good.
Yeah. Okay. So this was a very interesting thought expanding session we had with Mr. Ron, and I'm very grateful for this opportunity. So, and again, with further episodes, so to say, we're gonna talk with more people in the team and understand how everything is working in CV Global and Ahiravat, and then hope to see you guys when we have the engine data, and we're gonna figure out
All
who's
right.
gonna pay for the drinks. So, we're gonna see you then.
Okay.
Bye. Bye.
Sounds good. Thank you very much.
Bye.